Next, we're moving on to the Institute of Physics and their latest contribution in terms of a video with Tim.
Hello, my name's Timo. I'm an engineer who really loves science. I've come up today with 8 quick experiments to show physics that you can do on your washing line. And I have the props all around me, as you can see. So here you have physics on a washing line, 8 quick experiments brought to you courtesy of the Institute of Physics. Bird on the wire. You've probably seen these in the toy shops. It's the balancing bird. Put it on the line, and Pretty Polly, as I like to call her, sits quite nicely, can swing quite a bit, still doesn't fall off. It's a copy of Pretty Polly, and I made Plain Polly. Plain Polly's the same size, same shape, same everything. Put her on the line, she just wants to fall off. Try again. And with the balancer, she falls off. So what's the difference between Plain Polly and Pretty Polly? Well, Pretty Polly has got a weight in her tail, as you can see. And that means that Pretty Polly's centre of mass, centre of gravity, somewhere between her toes and that weight, around about there. So whenever she rocks, she's always been pulled down, and the weight tries to realign itself below the line. Whereas for old Plain Polly, her centre of mass and gravity is up here somewhere, so whenever she moves, she falls off the line. Now, a simple way of proving that is to turn Plain Polly into a Pretty Polly by sticking a weight on her tail. Sorry, Plain Polly, I'd appreciate in a minute. Got her on the line now, and now her centre of gravity is below her toes, and she, rather than pitching forwards, she always tries to balance on the line. Kissing bottles. Bottles come to. So the basic physics here is that fast moving air is the lower pressure in low moving or static air. So if I blow through the middle, the air is moving quicker relative to the air outside, which isn't moving with a nice still day. Because the pressure is lower, the bottles move to fill the gap of the low pressure, or, like to think of it, the pressure on the outside, which is higher, pushes them together. One last time. Kissing bottles. Couple resonant pendula. On my washing line I have 2 drinks bottles filled with plastic to give them some weight, for the same length, size and weight. Watch what happens when I start one of them swinging. Notice how it comes to a stop and the other one starts swinging, and then the other one comes to a stop and the first one starts swinging. So what's happening is, each time the pendulum swings, a little kick of energy is transferred to the washing line and down into the other bottle. And just like a child on a swing, a little push, repeatedly, they'll go higher and higher, and that's what's happening to the other pendulum. But because of the conservation of energy, the first pendulum will slow down and stop. And then the whole process goes in reverse with the second pendulum giving a little kick. And because the pendulum is exactly the same length, they have the same natural frequency, so the kick is just right to make the other one swing. So that's coupled resonant pendula. Ordinary drinks carton, holes punched in either side, opposite sides, connected to a piece of string, filled with water. Attached to the washing line. And you will see that as the water comes out of the holes, besides pushing it like that, That side's pushing like that, causing the thing to slowly spin round and round. Carlton carousel. In front of us we have a little crystal radio, or rather a modern equivalent of a crystal radio. The beauty of a crystal radio is that it needs no power. He picks up the radio signal from his aerial, and there's enough power in that radio signal to broadcast the sound into a little earpiece. Of course, if I had a little earpiece, then you wouldn't be able to benefit from what is TalkSport radio. This is picking up at the moment. So the little green pod down there is one of those external phone amplified speakers. Now the crystal radio, you might be thinking, what's that got to do with washing line science? Well, it needs an aerial. So I've rigged this up, and if we can follow the green cable here, you'll see my green cable going across my lawn, turning into a blue cable and then a yellow-green cable, because I just used scrap to cable, gone red, over the door, up, gone black. I hope you can still see that, and black then attaches to, focus in a bit, zoom in, my washing line. There you go, there's the washing line, there's a connection to it. I was lucky my washing line actually has a metallic core, so I stripped off some of the outer plastic casing and connected it with all this Heath Robinson bits of wire here. So just to prove that it is the radio that's picking it up, and not that little green pod there. I'm not cheating on you. This is the tuning apparatus for a crystal radio. It moves along the copper coil, picking up different frequencies. So if I remove the tuning pin, twist it up, radio stops. Put it down again,
Salah can play centrally when Firmino's not
and
there.
we get the radio. There you go, washing line science, the crystal radio. The gyroscope, a wonderful little toy, defies logic and always stands up despite its dimension. But can I get it to stand on the washing line? Well, let's have a go. There you go. So the spinning disc has something called angular momentum, and with momentum it always opposes any force given to it. But angular momentum opposes that force at 90 degrees. So as gravity pushes it down, it itself tries to right itself. The gyroscope. Bottle drop, or if you like, bottle catch. Another one of my plastic bottles tied to a shoelace. On the end of the shoelace are a couple of washers to give it a little bit of weight. I'm going to drop the bottle and hopefully the washing line will catch it before it hits the bucket of water. Indeed it does. What's happening here is that the bootlace has wrapped washing line a number of times. Eventually the friction of the bootlace is enough to stop the fall of the bottle. The reason it does that is that when we let go of the end of the bootlace, it falls with gravity, and so does the bottle. The bottle falling down pulls the counterweight that way towards the camera. So by the time it gets to the bottom, it's going that way and also that way, giving it the momentum to swing all the way round, wrapping around the line and stopping the bottle from hitting the water. You may have also seen this with a bunch of keys. Let's see if we can do similar with a bunch of keys very quickly. Yes, we can. And here it is in slow motion, wrapping itself around the washing line. No washing line science demonstration could possibly be complete without some simple rockets. No, one worked. Everyone worked. So that's it. Science on the washing line brought to you courtesy of the Institute of Physics. Do enjoy the rest of Science in the Park today, and if you'll forgive me, I have one final use for my washing line.